Hi guys, in this video tutorial, I will be implementing potholes detection and segmentation using YOLOv8. So in this project, we will create our own data set. So to create our own data set, I will be using RoboFlow so first of all, I will go to RoboFlow and this is the first link. So I have created my account. So if you haven't created your account, you just need to sign up. But I have created my account, so I will sign in, and it will redirect me to the site here. It might take few minutes. So then when you create your account, it asks you to create a workspace. So I have already created my workspaces. I will choose this. So let me show you few things. So if I go to settings and if I go to this, so when you create your workspace, please choose workspace plan as public plan. So if you choose the workspace plan as public plan, you can import or export any data set from the RoboFlow. But if you do not choose the public plan, you will not be able to export the dataset from RoboFlow into the Google Colab. So please make sure when you create the workspace, please choose the plan as the public plan. Okay, so then I will go to the projects and click on create new project. So this is basically instance segmentation, and what I'm getting potholes project name, pothole project new, because I have already created a data set for this. So I will in this for the video tutorial, I am creating a data set from very start. So I will just think project name as pothole detection project new, and I'm detecting potholes. So I'm just written potholes and project type as instance segmentation. So create a public project. So first of all, as we are creating our own data set, so we will take this video and just copy the link of this video and just paste it over here. You can also add some images or videos from your local system as well by clicking on select files or select folder. You can upload a complete folder of images as well. So let's see how many images do we get in this from this video when we split it frame by frame. So 1 frame per second. So we have 130 images, as this video length is also 2 minutes. 2 minutes 9 seconds is the video length. And if we take 1 frame per second, so we have 130 frame in total. So here we have 130 frame in total. Plus, so this data set will not be enough. So let's go to RoboFlow universe and see if we have some publicly available data set, so we can clone some images from there to our own data set as well. So in the meanwhile, it's uploading over here, and let's go to there as well. So it will take few seconds to redirect over here. Just click on universe and just write potholes instance segmentation. And just wait for a few seconds. Okay, these are 96 images. That is also fine. So let's consider this data set and let's see the images. And let's just click on select all over here. And just then I will go to, oh, let's clone 50 selected images. Click over here and it will ask you to select the workspace. Okay, no, I will not, don't want to select this workspace. Just going back. Okay, okay. Just go to the images, select all, clone 50, okay, pothole detection, which is the, okay, so it is recently created this project. I will just select it. Okay, finish cloning, and I will not import only images. I will also import the annotations as well. So I'm just 50, finish cloning. Go to clone images in the projects. Now let's see how much data set do I have over here. So currently dataset has 50 images. Let's see if we can clone the remaining images from here as well. Okay, just so these are the 50 images we have. Just checking, just let me see. Okay. Why can't see all the images? Just let me check it. I have just refreshed it and I can see all the 50 images which I have cloned from there. So now let's go to again over there and just clone the remaining 46 images as well. So basically in the first try we have cloned these 50 images, and as the dataset consists of 96 images, we will just go over here and clone this remaining 46 images as well. Okay, so clone 46 selected images and just go below and select, okay, and I will select this project and finish cloning 60 images. So it might take few minutes, but it will be done as well. So just let's wait for the few minutes so that it gets cloned into our original data set. So it's cloning images. Go to clone to see this. It's done successfully. So now let's see these images. So dataset consists of 46. Okay, that's fine. Generate. Okay, if I can, we have all the objects 50. So what I will do, generate new version. Okay, the dataset consists of 96. That's good. So we have currently 51 to 60. Okay, so that's fine. So we have all the images over here as well. That's good. Annotation, the remaining 46. Okay, so we have all the remaining 46 images over here as well. So that's fine. So, and this is the video from which we have created basically uh, now we'll have uploaded the video. Now I will annotate all these images one by one. Okay, so just save and continue over here. It might take a minute or so, so let's wait it completes and then we will annotate every single image in this. Although we will not annotate the images which we don't require, but we will annotate all the necessary images over here as well. So it is a bit time taking process, so let's wait for it to complete and then we can move ahead as well. So it is a bit okay. Okay, it's done. That's good. Okay, now the files are being uploaded over here, so it might take few more minutes. Okay, as I don't have any teammate, so I will annotate all those images by myself. So I will assign these images to myself. Okay, so now I will skip these images and start annotating from here. So as we are doing segmentation, so I will choose this and let me show you how we'll connect. You will just connect the dots here as well. And in this way, you will do the annotation. Okay, just miss the point. Okay, and just click over here. So we will assign the class as object, save and enter. And here I can also see a path hole. So just connecting over here. Okay, that's cool. And here I can also see a path hole over here. Okay, and then connect it over here and here. So we are just doing the annotation over here and now next move towards the next image. Okay, there are so many pathholes over here. Just do the segmentation. Basically, this is in the form of polygon shape. You can see over here. Okay, so that's my mistake. I just a minute and then connect it. Okay, so now for this, just do this 1, 2, 3, 4, and done. And for this as well, just connect those key points one by one. Okay, now for this as well. Okay, now for this path hole as well. So in this way, we'll annotate all of our images. Okay, that's means. Okay, so now we'll cover this path hole as well. So in this way, we'll annotate all of our images. Now go to the next image and just annotate it as well like this. In this way, you will annotate it. Now annotate this image as well. It might take few minutes, but it can be easily done. And okay, this is also a path hole. So this is not a very, you can say that tricky process. It's a quite easy process and you can do it on your side as well. And you can do it for any data set of your requirements of your choice. Okay, okay. Then let's do for this image as well. Now I'll just pause the video and I will do for all of the rest of the images, and then as I complete the annotation, then I will get back and then we will move towards the training process. So guys, I have completed the annotation process completely. So you can see that we have previously 96 images. Now we have a data set of 202 images. Now let's go to generate section, and we don't need to apply any pre-processing, just these two: pre-processing, auto orient and resize. These are enough. And then select augmentation, just skip it and then generate. So now I will click on generate. So it might take few seconds. So one thing I tell you, we can train our model using RoboFlow as well. It's a quite simple process to train your model on RoboFlow. By clicking on start training, you can train your model on RoboFlow, but it's better if we go if we train our model using Google Colab, because there is a thing where we can learn some new things. Here there is a no basically RoboFlow provides a no code solution, so it's involved no coding, but by just using a single click you can train your model at on RoboFlow. So just exporting the zipping file, it might take few seconds, so just wait until we are able to export these files. So here we have the code. So using this code, we will import the data set, this data set into our Colab file. So okay, so first of all, let's open the Colab file over here. Just click over here and just Google Code. Just open the Google Colab. So for the implementation of this project, I will be using this repo. Okay, so although we are not implementing the tracking, but I will exclude the tracking from part from there here, and we will use this repo. So you can, I will add this repo link into the description of this video. You can check this repo and use this code for this project as I am using it now. Okay, so let's open the file which we can use, for example, for let's, so we will use the instructions provided in this file. So just go over here, create a new notebook. Okay, and I'm creating a new notebook and just write pothole segmentation, pothole segmentation, YOLO. Potholes segmentation using YOLOv8. So let's open this for the file. So we will just following the instructions from there. So select the GPU before you run the code. Okay, so I will just go to runtime, change runtime as GPU, and because it will speed up my training process. Then I will import the required libraries. Just write import the required libraries. So importing all the required libraries over here. Now let's click on this cell to run so that this cell can run. Then we will clone this GitHub repo. So just go over here and click over here, and now I will just clone this GitHub repo. Either just write clone the GitHub repo. Okay, so just cloning this GitHub repo over here. Okay, so it will take few seconds until we are able to clone this repo. So we have this repo over here. Now we will set the directory as this repo. Okay, just copy path and set the current directory. Okay, so percentage CD is used to set the current. Then we will install the dependencies or all the dependencies over here. just write install all the dependencies. So to install dependencies, just write pip install -e dot dev. I think just missed something over here. It should be like this. Mm, but it's working fine in that case as well. But if you can add column, it would be very much good. So after this, as I am implementing segmentation, so I will be redirected to this YOLO V8 and this segmentation folder. Just basically we are installing the dependencies means we are installing all the required libraries. Like you can see over here, we have installed request, pigments, Jinja 2, Markdown, Ultradetix, all these libraries here. So it is good to before we install all the dependencies. So when we are training our model, we don't face any library issue. Moving towards the segmentation directly, moving to the segmentation directory. So, okay, so this is my segmentation directory, just percentage CD. Now just check our present and direction, present working directory. So here I'm just checking my present working directory. Okay, so now I will import the dataset into access from RoboFlow. Just keep this. Okay. Import the dataset from RoboFlow into Google Colab. Into the Google Colab. Okay, so just go over here. Just copy this path and just take here and just write enter. Okay, so here I'm just downloading my dataset and it will be appearing over here. It's not currently appearing, but it will appear as it downloads. So you have to see loading RoboFlow projects downloading over here. And you can see the dataset over here as well. Okay, that's cool. So we have the train test validation folder, data.yml folder. Okay, so here is our data.yml folder. Okay, that's fine. So now, basically, I will just train my model over here. Just give me a minute. Now we will train our models. To train our model, let's try training the model. Okay, so just set the first this as okay. So this will be your home directory, and okay. So first we can set a dataset dot location as well. What is our dataset dot location? Let's check it out. Okay, our dataset is over here. That's cool. Now just set percentage CD as home and just write Python train.py. If I am missing anything, let me check. Okay, so basically this predict.py might create an error because it's been adjusted for the tracking as well. So let me upload the updated predict.py file, which I will have in my YOLOv8 folder. Okay, Analytics, YOLOv8, just go over here and just in the segment, just select this spread. I will just upload this predict.py file as well. So you can choose it as well. So Python train-.py file model is equal to YOLO v8l.pt. And is next thing which I need to care of is let us just check. I think I might be missing something. Just go to this GitHub repo and just check that training. I think training part is not written over here. So training, basically just copy this code. Okay, just this code over here. Okay. Okay, so we can just change it to 120 epochs. Now let's train our model. So we are just starting to train our model. Let's see how much time it takes, what we come attempted to train. Okay, let me check this error. I think it should be a very small error. We can fix it now. So I have just checked the YOLOv8 alternative YOLOv8 repo. So there is an update. So we need to update this. And I think when we run it this now, it will hopefully work fine. So just have made this update and now running the script again for 120 epochs and nothing more than that. So let's wait until the script runs successfully. So it's set started. So it's the size of pre-trained model is 88 MB. Basically, we are fine-tuning the model over here. Dataset not found. Okay, option one. Okay, let me check this issue as well. So there was a path issue, so I was able to fix this issue. Now we are ready for the training, and the training has started now. So let's wait for the training to complete, and then we can test our model on some sample images and check out how our model performs. So just let's wait when our training completes, and then we are going to test our model. So the training is going on, and let's wait for it complete. Mean average precision is a bit low at the start, but I believe as the model trains, it will definitely improve. Now let's check what mean average precision we are getting. Okay, so it's increasing now. So the training will be continued. So let's meet after the training complete, and then we will test our model. Sure. So the training has completed and we are able to get a mean average precision of 0.532 with IOU of 50. And when the IOU varies from 50, 0.50 to 0.95, then we have a mean average precision of 0.218. It's not very good, but it's okay. Plus, now we are testing our model. So we are downloading a sample video over here, which name is demo.mp4. And now we are testing our model. Here I have already tested the model on a sample video demo.mp4, and these are my best weights, and using predict.py I'm testing my model on a sample video, and here are the results which we get. You can get that model works fine. It is able to detect the path holes, so the model works fine. Like it is not. Then we are testing on a demo video too. Just downloading demo video too and tested my model on it. So as the demo video, as the demo video too was quite big, so we are unable to display it over here. But I can show you the results as well. I have already downloaded here the results. So we can see this video is a quite long. Okay, so you can see here the model was able to detect the path holes. So our model works fine. Okay, so we can say that the model working is quite fine. Plus, we can also display the confusion matrix over here. To display the confusion matrix, like just write display confusion matrix. Okay, so just to display the confusion matrix, just write it over here. And just by clicking over here and then going to where we have, okay, runs detect. No, here we have YOLOv8 segment. Then, okay, where we have the files. Okay, we have the files over here. So here we have the confusion matrix. Just copy path, and just write image, and just add this copy path over here. Just copy the path from here and just add it over here. Now let's see what we get, whether we have not. Okay, so just need to run this cell. We have missed this cell. So just running this cell and now just running this. Okay, so this is our confusion matrix. So confusion matrix basically tell us how our data is distributed among different classes. You can see here our model is able to detect 50% of the path holes, while on 50% of the time it fails to detect the path hole and it gives nothing. It did model detects nothing. Like this is a blank screen. We have nothing is detected. Okay, so this is the way. Plus, we can also validate the custom model as well. I will take the validation of custom model code from here. And just now, let's validate the custom model as well. So just uh, validate custom model. Okay, so we have that. I think I should add the best dot weights path over here, which is here, and just copy this path and just add it over here. I think it should now be working fine. Let's see what the results do we get over here. Okay, okay, I think to fix over here. Another issue, another day. Okay, okay. So what I did it at train.py, I will do the same in what I did in predict.py, I think. I will do the same over here. Just copy this and paste it over here. I think it will now work fine. But just check it again. If there is an issue, we will fix it again, but I believe it will work fine now, but let's see how it works. So checking the model and see how does it works. Okay, so it's working, I think, fine. Okay, in the meanwhile, it comes, let's say, predictions on, let's display the prediction on the validation batch as well. Okay, so on the when we validate the custom model, we are able to get a mean average precision of 0.538. With segmentation, we are able to get a mean average precision of 0.531. So it's not very good, but it's quite fine. You can say that. Now we are printing the prediction on the validation batch. So just write image here and just write over here validation batch predictions. So now let's display the predictions on the validation batch, which we have over here. So we can see that the results are very fine. Okay, so this we have also done confusion metrics. We have tested our model on multiple demo videos, and our model works very fine. So this is all from today's lecture. See you in the next video. Till then, bye bye.